Okay, hi guys, can everyone hear me? Yep. So my name's Dave Connor. I'm the VP of Business Development for CLC Group. CLC Group are a blockchain lab of professionals, and we're focused on building projects in the decentralized data space. Our main offering at the moment is a project called Honeycomb API Marketplace. What I'd like to do today is to focus on Honeycomb. The way that we basically have built it to make providing data for smart contract and app development use cases as easy as possible. So I'll discuss more about that, tell you about how it works, and I'll give an example of a project that's built on it and how easy it can be to use. So the first question really, it's quite easy when you come to a blockchain-based meetup to forget the question of why you would want to bother decentralizing everything. It's not every application needs to be decentralized, but there are quite a lot of advantages in doing it. With the traditional centralized kind of applications, which I'll probably be referring to as Web 2 applications during the talk, you have a centrally developed, centrally controlled application. There's a lot of trust involved in that. You need to trust that the people who run the application will actually do what they say with your information, with things like data processing, information storage, also that they'll do what they say when you pay them, if there's any payment involved, and whenever it comes to refunds, that they'll make sure that works. Sorry, it's a bit squeaky, let me move this further away. Okay, that's a bit better. So examples here are things like Uber and Airbnb. They're very, very useful applications, but there are some concerns over data privacy. And you also have the kind of centralized legislative side of things, where cities can come in and they can say to Uber, you can't operate in our city, and then that's it. They can't work. With decentralized applications, everything's a little bit different. You don't have to trust anyone to run them. They run on permissionless blockchains, for example, Ethereum. Anyone with internet access can interact with them, so you don't have this inability for certain demographics and certain markets to actually use them. There's trustless execution. You know that the code is there, it will run exactly as it's intended to, and it should always run as expected. And it removes single points of failure. You can't really hack Ethereum. It's a much more difficult thing to do than to target servers for Uber, for Airbnb. So you shouldn't see any loss of info, and it's very unlikely that the decentralized applications will be subject to downtime. So our ethos behind Honeycomb really is about bringing Web 2 level connectivity into Web 3 level dApps. So most existing Web 2 applications will rely on quite a large number of APIs to operate. And the best example, I keep falling back to Uber for things like this. The Uber functionality is achieved by knitting together APIs from different sources. So you've got Amazon for their infrastructure, Braintree for their payments, Twilio for their communications, and Twilio's SendGrid for their email communications, and you've got Google for their mapping. So whenever you're opening Uber, you're consuming data from a variety of different providers, even if you don't realize it. And an important thing to add here is that APIs, a lot of people might see them just as data sources. But actually, the main thing, or one of the main things they're useful for, is outputs to the real world. So you have things like text messages, emails, ticket purchases, buying items, sending post. They can all be triggered by APIs, and they're really important for any decentralized application that actually wants to have real world outputs or inputs. So the question really is, why is Web 3 restricted in terms of the APIs it can consume? Quite a while ago, Web 2 had very few data availability, or had very low data availability for the applications built on it. The early days of the App Store, you had things like random number generators, you had applications that would fake drinking a pint of beer, you had very simple games that didn't really have any external inputs. That's about where Web 3 seems to be right now. So the issue is what's preventing all of these other sources that are there that can be used by existing applications. Why can't blockchain apps use them? And the main thing here is the Oracle problem. I know that this was mentioned earlier, so I won't go into it in great detail. And if anybody here doesn't know about the Oracle problem by now, I'd be very surprised. But essentially, if you make a smart contract rely on one oracle for external data, it removes any benefits from decentralizing the application level. When I say an oracle, what I mean is, I think the term oracle comes from ancient Greece, where an oracle was the person who'd communicate between the mortals and the gods. And that's the way it's used in blockchain. An oracle provider is someone who allows blockchains, aka the gods, to see what's going on in the mortal world. So traditionally, it's one person, or one entity, that would then provide data in a form that can be consumed by applications on the blockchain. So if you have this traditional setup, the oracle provider becomes your trusted source and your central weakness, in that you could have a multi-million-pound contract running to do with the football results, but if the oracle provider decided to input the incorrect result, no matter how secure the rest of that contract is, it's meaningless because you're still relying on one entity. And you can have innocent mistakes as well. If the oracle runs off one data source, if that data source is corrupted, then you'll get an incorrect output too. So this is the oracle problem, and this is the main kind of obstacle to seeing more data variety and more data sources, and in fact any data really for blockchain. And there's a brief rundown of it. Essentially, without the ability to give end-to-end trustlessness, including the oracle layer, it becomes cheaper to ask the person who you're trusting to run that oracle just to run a database for you instead. So the solution is decentralizing the oracle layer. Chainlink allows data from multiple oracle providers to be aggregated. The aggregation can involve multiple APIs, and it removes the ability for one node to influence results. This helps eliminate API downtime, causing problems, as long as you've got multiple data sources available for the contract. But you all knew about that already. So, to provide this level of decentralization for the data that Honeycomb offers, we've built it on Chainlink. Chainlink works by allowing anybody to run a node, as Johnny said, and they can use it to offer data to smart contracts. So each node can offer data from open APIs, unauthenticated APIs natively. They don't need any extra software developed for that. But for any authenticated API being used, you need an external adapter built, which is an extra piece of software that connects to the node and hides the API key and allows access to the API itself. So the links on the slide give examples of the people and companies that are currently running the nodes. So again, we see Chainlink oracles as being the solution to what we're doing and what we're using to provide decentralized data. What we're doing with Honeycomb is to try to improve a number of things for developers. So we're looking to get more data sources, more data variety. We're looking to make it easy to combine this data in a reliable, decentralized way. And we're looking to find a way to make it easy to test and easy to include in decentralized applications. But there are a few technical, legal, and business development obstacles that we see being present that we've designed Honeycomb to solve. So the first kind of technical challenge, not really challenge, the first technical obstacle is that connecting the Chainlink node to an authenticated API needs that external adapter. So this needs to be developed and also kept updated. It's easy for someone to develop an external adapter, upload it to a marketplace for people to use, but if that developer isn't keeping track of the API's endpoint specifications, then it's useless. If the API endpoints change, you can then lose access to that won't work. And this can be done by the node operator or the developer or an interested third party, but you need to have somebody who's then keeping track of everything as well as developing it initially. Like I said, linkpools market.link does list these for node operators. For network development, you have a problem with subscription API availability, potentially, where it's like a chicken and egg situation. If an API has to be paid for and subscribed to, then who pays for it? So normally that would be the node operator. But as a node operator, why would you pay to supply data that there's no demand for? Because node operators are paid each time the data is used. If you know that there's demand, you would then subscribe to an API to be able to provide that and make some money from it. But if you turn it the other way around, why would you as a developer write a smart contract or an application that uses data that isn't available yet? And that's quite a big obstacle that we see. And this gets more significant as API prices increase, which means that the higher quality, lower latency, high uptime APIs are going to be harder to get on the network in the same way that the very, very cheap hobby APIs wouldn't be. And also, as the required node count increases, this becomes much more of a factor. There's a small legal point as well. We've spoken to a lot of API providers as part of building Honeycomb. They see the standard node operator usage as potentially be reselling data. So you may well be running into problems with APIs terminating service later on if they decide that suddenly Chainlink use is significant enough that they want to get extra fees from it. And the last point really is awareness. People need to know that the API is there, that people can use it. The node operators need to be known, they need to be out there and visible, otherwise they won't get used. And people need to know that the application exists, because without end users for the application, there's no source of income for everything else going upstream. So all of these barriers exist at the moment, and they make it harder, not impossible, to use external data widely in decentralized applications. Removing as many of these as possible is what we see as being key to opening up the Web 2 style use cases much more quickly. And I'll demo a project built using Honeycomb later on, and you can compare it to the kind of smart contract style interactions that you may have seen in other demos. It's not to say that it's not built on a smart contract, it is, but with a graphical user interface, it makes things a bit easier to see how we anticipate Web 3 dApps evolving. So the main ways that we've built Honeycomb to get over the problems that we see, we've written external adapters for all of the APIs that we solve. So this is something that we do from day one. If somebody has an API that they'd like to list with us, we make it clear to them that we can write the external adapters. We take care of that. We don't charge them a fee for it. And we make these available to all the nodes that we work with. So that if we say we offer weather data, that weather data is available on all the nodes in our marketplace. And neither the node operator nor the API provider have had to write any kind of software for that. We take care of it. We offer per call pricing instead of subscription. And this is quite an important difference to most APIs models. So the reason that works is that you can have a high value API that wants to be expensive, but if they charge that per call instead of as a fixed subscription, then the node operator can sit there and offer that data potentially until it's ready to be used, and they'll only take the fee when they've added their fee on top. So node operators will never lose money offering a huge number of different APIs. The APIs will be there, people can use them, and the costs are only made when the APIs are called. We also offer pre-negotiated service agreements to get over the legal side of things, where API providers expressly state that they know what we're doing, they know the use case, they know that it's being offered over this marketplace, and they're happy with it all. So, and they basically sign to say that they understand it, and everything's kept on very good terms with them. And we also offer free test calls to encourage development. So we let you test the integration, and we offer free calls over Ropsten, so that you only need to start paying for the data when your application is ready to enter production. And we do all of this by mainly, we believe that the fourth industrial revolution wouldn't work without getting the data providers themselves on board. So we speak to the providers, we talk them through smart contracts, we get them interested in the space, and as a result, they're able to work with us, and they're willing to help us by offering these free calls, changing their pricing models, and it should all work very well. So currently, we're kind of stage one of the marketplace. It's really developer focused. So it's aiming to promote network usage by improving the availability of external data. So it's all about lowering barriers of entry and just letting developers focus on their application rather than having to source APIs, develop adapters, find node operators, manage subscriptions, everything like that. They build what they want to build, and we make it as easy as possible for them to plug external data into that. There are a few examples of applications available that have been built as a result of we had a hackathon at the end of last year. The website is honeycomb.devpost.com, but I'll pop this link up at the end. So they're good examples to look through for external data, and they were all written in under 3 weeks. So let's show you the website itself. See if it opens in here. No, it's in the other one. So this is our actual marketplace. So if you scroll down, it's basically got listings of all the APIs that we offer. If you click on one, so Aviation Edge is for flight data and flight tracking. gives you the prices for each call for information. That's the lowest price. So if you wanted to, say, have a look at the airline database, if you wanted to test it quickly, you can enter your JSON there, click on execute, it will give you the results. And then when you decide you want to test it a bit more, once you've actually got your app there, you can click on either Ropsten or Ethereum, go to the main network. And once you select the data type that you expect from that endpoint, it'll give you an example if the Oracle's capable of serving that. And if I actually go to the window, it's only just opened up, sorry. Yeah. Yeah, and then it should give you the pricing link for that information and the dollar price as well. So it gives you an idea of how much you'd be looking at per call for each call that your application is going to make, and it gives you the job ID for that if you want to get on straight away and get that implemented. Right, let's get rid of that. No. Okay, so when I talk about our nodes, the nodes that we work with, we're partnered with 6 of the Chainlink official nodes. So these are the nodes on the data feeds that Johnny was showing. And we're also a node operator as well. So the nodes we work with are all up there: Certus1, Linkforest, Stakefish, Nodepool, Cosmos Station, and Simply VC. We currently have 21 APIs available. There's over 10 in the process of being listed as well on top of those. These are, they provide quite a large number of endpoints. It's 300, well, over 300 different endpoints easily. I think actually when I spoke to Barak, he said we're currently running over 1,000 external adapters as well. So, and the link marketplace lists 25. So we've really done quite a lot of work on the external adapters and the data availability side of things. The data types that we offer really vary from standard use cases, such as the obligatory crypto price data, through to more interesting things. We have text sentiment analysis. We have news headline analysis. So you could write a contract saying, if the stock market news the next day is bearish, then sell everything, which would maybe not have been too bad an idea. And everything can be done with the APIs that are already listed there. So we even have flight data, weather data. Where possible, what we try to do is to duplicate, not data sources, but duplicate types of data. So for weather data, we have a few different providers. Flight data, we have a couple of different providers. So you can decentralize everything, not only by calling over 7 nodes, but you can call over a few different APIs as well to prevent API downtime being an issue. And the hackathon projects that we did ran from things like event insurance to crop insurance, weather futures trading, sports lotteries, and a couple of different teams wrote a decentralized Ethereum to Bitcoin swap as well. So I'll just show you one of the projects. This is EV, which is event insurance against adverse weather conditions. So it's quite a nice, simple application, really. What you do is log in with your MetaMask, and then you work out how much you would like compensated for your insurance. So, so chosen the silver, then you put in the information about your event. So in this event, it's in a field in Germany. You put the date and the time for your event. And then it calculates the premium. There you go. And then click on finish. And what that does then is it lets you pay the premium calculated for that particular area for the payout that you're going to receive. So it's an example of a type of insurance called parametric insurance, which is where you have the insurance provider will work out the risk that you're undertaking. The insurance provider will work out what premium you should pay to be covered for a certain level of payout in the event of certain conditions occurring. EV uses this to look for adverse weather events. So it just looks for a volume of precipitation in the kind of first version here. So it means if you have an outdoor event, like a cricket match, that you'd like to cover in the event of it being rained off, you can do that quite simply. So, and then once it's been done, once it's gone through on Ropsten, you can bring up the detail of your contract if you want to have a look at it. And then once you log out and log back in, or you can go away from the website and come back, then it actually brings you up details once you're back in on your MetaMask, based on your accounts, about the previous policies you've taken out, if they've paid out, if they've not, which this should bring up in a second. There. So there you go. So it's quite an easy way of visualizing the whole insurance process, and it's all, although the risks might be calculated by the company themselves, the payments process to get the policy set up and the policy paid out are all done on blockchain, and it's a front end for the kind of contract that Johnny's seen, but it makes it a bit easier to understand. So our next steps the next step is always adding more APIs, because if you look at Rapid API, they have something like 15,000. So we see the not being too bad. Well, there's no such thing as too many APIs being available. We're partnered with Oracle as part of their Oracle for Startups blockchain project, and we're going to be listing the APIs that their projects are able to provide. We're always interested in making it easier for data providers to list. Like I said, it's literally as easy as them giving us an endpoint at the moment, an API key we can use for testing and signing a contract right now. And we're trying to find out a way to make it even easier than that. We're interested in improving the number of nodes that we serve data over. The long-term goal is to make it essentially unlimited, and once there are reputation systems online, we can make it so that nodes with a certain level of reputation can automatically be added. But obviously that's a way down the pipeline, and we'll follow everything that's going on before then. And the end goal really is to be an ecosystem hub where you have APIs listing because developers are there to find APIs to use. You have node operators joining because they won't lose money. They'll be connected to all these APIs without having to pay subscription fees. And developers go there because they know that there are APIs that are there, that are decentralized, and that are provided by a large number of nodes as well. And that's everything. Thanks for listening, guys. There's more information about everything up there, but does anyone have any questions?
Are you integrating into Hyperledger?
Sorry?
Are you going to integrate into Hyperledger with APIs?
At the moment, we're just on Ethereum, but I wouldn't rule it out. We're looking into other blockchains.
If it's REST APIs, it would be easy enough to
Yeah.
Yeah.
Yeah, I'll speak to our CTO about it. So. Yeah?
So when you refer to something called a node operator, they are essentially an intermediary between the API and the app.
Yes, yeah, essentially. So the node operator is the Chainlink node operator. So they're the ones who retrieve the data from the API and make it available for consumption by a blockchain application.
So if your data source is only a single source of data, it's only a decentralization.
It's not, so you can still decentralize it at the node level. So if you only have one node, even if there's only one data source, if your node operator goes down, then you lose access to the data source. If you have a number of nodes, then you're more resistant to a single node going down. And if you aggregate between the nodes, then even if one node provides false data, then you can basically eliminate that. So yeah, even if there's only a single data source, multiple oracles are still useful. Obviously, multiple oracles, multiple data sources are much better, but yeah. Okay, thanks guys.